Hi, I'm Jim O'Donnell. I'm a lead application architect with Humana, and I'm here to talk about our how we DevOpsed Splunk in our environment. We started off with the challenge of building out a new enterprise environment for our top 50 applications within Humana, as well as simultaneously building out an enterprise cybersecurity platform, which required data segmentation between the two groups. So what we decided to do was to grow our current environment from 16-node indexer cluster in a single site to 2 multi-site clusters between 2 sites for a total of 146 indexers. The intent was to segregate the IT operations data from the security data, as well as design the environment for more simplified management using DevOps principles, such as code branches, and as well as automated releases of the environment. So to start off with, some of the numbers that we worked out. We started off with 171 new servers in 2 data centers. We had 30 indexers for the IT operations cluster for a total of 60, 43 per site for our cybersecurity cluster for 86 in total. We have 6 nodes in a search-ed cluster running ITSI, and 4 nodes for a search-ed cluster for one of our line of business applications. We have 3 standalone search heads for various other search and reporting needs. We calculated that if we were to do this manually, this would have taken over 2,000 hours of time. We configured and had all of it ready to go in 10 minutes. So just a little bar chart to illustrate the difference in time. So why did we do this? We did this so that we would have consistent configurations throughout the entire environment to eliminate somebody getting onto a server and potentially having a one-off configuration that was slightly different than the rest. Having standardized patterns for how we deploy our applications, as well as how we built the environment. Repeatable processes for the entire build, deploy, and retirement lifecycle. Decreasing the time needed to configure our new servers from weeks to minutes. Eliminating inconsistent human errors, as well as no longer needing a higher medium level of expertise for building and configuring new servers. So how this works. We use ServiceNow for building the virtual machines. And we use Puppet in addition to that for putting down some of the prime applications on the servers, such as the antivirus and doing configurations for ulimits, transparent, huge pages, settings like that. When Puppet finishes setting up the server then checks immediately into our deployment server. And once we've added that host name to our deployment server, it pulls down the configuration changes, does what it needs to do. We have consistent apps for setting up the admin accounts, and then it's ready to go. Visualizing the build process, we have a request that starts over here. Person requests the VM. ServiceNow builds the VM per our specifications. Puppet does the work. We have additional, when we originally did this, we had one additional step, which has been since ported over into ServiceNow for adding additional virtual machines. At this point, there's a handoff to our team, and this is the amount of time for building out the 171 servers was 10 minutes from this point. And prior to this implementation with ServiceNow, Puppet, and our configuration, this portion of time would have taken 30 to 90 days. We had this completed in 7 minutes for another huge bonus. ServiceNow builds a new VM as per the specifications. Puppet's installed, a second NIC added, and then we have our additional drive mounts added to it as well. A little more detail. Puppet makes the ulimits and THP changes, sets up drive mounts, adds root access for our team, installs Splunk, and then ensures all the configurations exist. At that point, all you need to do, add the server to the build server class and reload. Wherever possible, we used common apps for the configurations, admin account access, Active Directory setup, license master connections, disabling KV store where not needed, disabling the deployment client when the server first checked into our build deployment server is also in there. Our indexer clusters, they have specific rule sets for each cluster for setting up the primary build apps as well as the indexers. We built specific applications for putting together the search heads because normally that cannot be done without Puppet or manual intervention on the command line. Splunk currently doesn't support any method for configuring a search head cluster through any other means, through standard config files. And caution, giant wall of text. And this just kind of goes into some of the details. But basically, the captain needs to be built prior to any search head members joining it. So we put together a script that would check to see if the cluster, if the captain was up before the other nodes could join into that cluster. And this is the script that we put together. Has the admin passwords and kind of blocked out here, but this is what we put together. So that goes out, it's deployed along with all the configuration scripts so that the search head clusters can be automatically created. Now, for managing the code between our environments, we have 3 long-running branches within our code base. We have a development branch, a QA branch, and then a production branch. Everything is checked into our Git repository running on TFS. And in order to ensure data quality and code quality between branches, we enforce reviewers between each branch. And then we have automated the release process from our code repository out to our deployers, cluster masters, and deployment servers. Once that's done, UAT has been completed in the QA environment. Then we require 2 code reviewers to review the difference between QA and production to ensure that what's going to be going into production meets quality standards. And again, automated releases from the Git repository into our production environment. And that is how we've done DevOps at Humana for Splunk.